In section 3.3, we are going to be looking at dividing polynomials. We're also going to get the remainder and the factor theorems. So the first thing we're going to do is use long division to divide polynomials. Then we're going to use synthetic division to divide polynomials. Then we are going to evaluate a polynomial using the remainder theorem. And lastly, we're going to get the factor theorem to solve a polynomial equation. All right, before we begin our division of polynomials, let's review long division in arithmetic. So we're going to divide 3,983 by the number 26. And it's important that we actually know what these things are called, because when we start doing long division of polynomials, we're going to use the nomenclature of division frequently. So the thing that you're dividing, the number that's being divided, is called the dividend. And the number that you're dividing into that dividend is called the divisor. And what you get when you're done with your division is called a quotient. So let's set this up and then we'll label everything. So we write down our dividend and we use a division bar. So we separate our dividend from our divisor using this half rectangle, a division bar. And we're going to write the divisor outside of our dividend. So again, this is our divisor. This is our dividend. And what we get when we're done is called a quotient. Now we'll not only get a quotient, but we'll get a remainder. The remainder may be the number 0, but we do get a remainder. All right, so how did you do long division in arithmetic? So the first thing you do is you look at your divisor and you determine whether go into the first number in your dividend. Will 26 go into 3? No. All right, so then you add the next number over, the 9, and you say, well, will 26 go into 39? And the answer is yes, 26 will go into 39. As a matter of fact, 39 divided by 26 is 1 plus some remainder. Okay, so that number 1, 26 will go into 39 one times with something left over. The number 1 is the first number in your quotient. So now you take the first number in your quotient, you multiply it by your divisor, and you're going to subtract that from your dividend. So you take 1 times 26, you get 26, you write that underneath the 39, and you subtract. 39 minus 26 is 13, and that's your remainder. So when you divide 26 into 39, it goes once with a remainder of 13. All right, so now we still have 2 numbers left up there in the dividend, so we need to take care of those 2 numbers. So we're going to bring the number 8 straight down, and now we have a new dividend. The new dividend is 138. So we're again going to see, will 26 go into 138? Yes, it will. It'll go 5 times plus some remainder. So the 5 is our next number in our quotient. We write that down. So now we take the 5, we multiply it times the divisor 26. 5 times 26 is 130. You write that underneath your dividend and you subtract. So now we get a remainder of 8. So 26 will go into 138 5 times with a remainder of 8. I still have 1 number left up there in my dividend, a 3. I'm going to bring that straight down. So now I have a brand new dividend, 83. Again, will 26 go into 83? Yes, it will. 26 will go in there, what, 3 times with a remainder. So the last number in our quotient is 100, the last number in our quotient is 3. So we take the 3 times the 26, 3 times 26 is 78. Write that underneath our dividend and subtract. And since we've now used all the numbers in our dividend, we are done. Our division is complete. So our quotient in this division is 153. Our remainder is 5. So the quotient is 153, and the remainder is 5. And typically the way we write this in arithmetic is we say we've got the quotient plus the remainder, and we write the remainder over the divisor. So 3,983 divided by 26 is 153 with a remainder of 5. And with the way we write that is 153 plus 5 over 26, which we can just write as 153 and 5/26. Okay, now you also may have learned back when you were doing long division in arithmetic that you can always check a long division. And the way you can check your long division is by taking your quotient, multiplying it by your divisor, and adding your remainder, and you should get your dividend. If you've done your division correctly, quotient times divisor plus remainder equals dividend. Quotient times divisor plus remainder is dividend. All right, so how do we apply this to long division in polynomials? So now we're dividing x squared plus 10x plus 21 by x plus 3. Well, you set it up exactly the same way. So my divisor is x plus 3. My dividend is x squared plus 10x plus 21. And I'm going to get some quotient when I'm done. All right, so how do I determine what the first value is in my quotient? Now, since I'm dividing a polynomial by a polynomial, my quotient's going to be a polynomial. And in this case, it's going to be a polynomial with more than one term. So what I'm looking for is what is the first term in my quotient. Remember, in algebra, terms are things being added or subtracted. So how do I determine the first term in my quotient? It's actually fairly straightforward to figure out what the first term in your quotient is. So to find the first term in your quotient, you take the first term in your dividend and you divide it by the first term in your divisor. So in our case, the first term in our quotient will be, first term in the dividend is x squared. First term in the divisor is x. X squared divided by x is x. So the first term in our quotient is x. I'm going to write that above the division bar. Now in arithmetic, what did you do at this point? You took the first number in your quotient, you multiplied it by your divisor, and you subtracted it from your dividend. We do exactly the same thing. We take the first term in our quotient, multiply it by our divisor, and subtract it from our dividend. So we take the x, we multiply it times the x plus 3, first term in quotient times divisor, x squared plus 3x, and we subtract that from our dividend. And if there is any difficulty at all in the process of long division, It's this step right here. In arithmetic, when you write this value underneath your dividend and subtract, you don't even think about it. The subtraction is automatic. You just subtract. But as soon as we add the variables in the mix, it gets difficult to remember that you're subtracting. You are subtracting x squared plus 3x from x squared plus 10x. And you remember, when you subtract an algebraic expression, you change the sign of every term in that expression, and then you add. So I actually write down that change in sign in my long division so that I can remember I'm subtracting. So I have plus x squared. That's going to be minus when I subtract. I have a plus 3x. That's going to be minus when I subtract. So I'm subtracting x squared minus x squared. That's 0. And that is what should happen if you've done your long division correctly. The first term in the dividend and the first term in this product should add to 0. They should subtract off. Okay, now let's go to the second term. I have 10x and minus 3x. 10 minus 3x is 7x. So I'm going to carry out that subtraction. All right, now I still have a plus 2 in my dividend. So I'm going to bring that down. And I'm going to repeat the process. So to get the second term in the quotient, I take the new first term in my dividend. When I brought that 2 down, I got a new dividend. The first term in that new dividend is 7x. I divide it by the first term in my divisor, and I get 7. And that is the second term in my quotient. Now we take that 7, we multiply it by the divisor, and we subtract that from our dividend. I see I got an error there. That should be 21. It's x squared plus 10x plus 21, and I had written a 2. I apologize. That should be 21. 7x plus 21. Okay, now I'm going to change the signs to remind myself that I'm subtracting. 7x minus 7x is 0. 21 minus 21 is 0. So the remainder here is 0. Okay, so when I divide x squared plus 10x plus 21 by x plus 3, I get x plus 7 with a remainder of 0. So the quotient is x plus 7. The remainder is 0. Now, you may recall from arithmetic that if you get a remainder of 0, that means that your quotient and your divisor are factors of your dividend. For example, if you divide 12 by 3, you get 4 with a remainder of 0. And you know that 3 and 4 are both factors of 12. So in this case, the dividend is equal to the divisor times the quotient. And the same is true here. Our dividend, x squared plus 10x plus 21, is equal to our divisor times our quotient. And if you multiply that out, if you FOIL that, sure enough, x plus 3 times x plus 7 is x squared plus 10x plus 21. So what's important here? If you do a long division and the remainder is 0, that means both your divisor and your quotient are factors of your dividend. So here is our long division of polynomials process. First, arrange the terms of both the dividend and the divisor in descending powers of any variable. 2, divide the first term in the dividend by the first term in the divisor. The result is the first term of the quotient. 3, multiply every term in the divisor by the first term in the quotient, write the resulting product beneath the dividend with like terms lined up. Subtract the product from the dividend. Bring down the next term in the original dividend and write it next to the remainder to form a new dividend. Use this expression as the dividend and repeat the process until the remainder can no longer be divided. This will occur when the degree of the remainder, the highest exponent on a variable in the remainder, is less than the degree of the divisor. All right, let's do this one for practice. Divide 4 minus 5x minus x squared plus 6x to the third by 3x minus 2. And I do need to rewrite that dividend in descending order of powers on x. So I need to write this as 6x to the third minus x squared minus 5x plus 4. And I'm dividing that by 3x minus 2. So let's write down our divisor. Outside a division bar, let's put our dividend inside that division bar. All right, so to determine the first term in my quotient, I take the first term in my dividend and divide it by the first term in my divisor. 3 will go into 6 twice. X to the third divided by x is x squared. So the first term in my quotient is 2x squared. I take that first term in my quotient, I multiply it by every term in my divisor. So that's going to be what? 6x to the third minus 4x squared. And we write that under our dividend. Change the sign and add. 6 minus 6 is 0. I have negative x squared plus 4x squared. 4 minus 1 is 3, so that's going to give me 3x squared. Now we're going to bring down the minus 5x to create a new dividend and repeat the process. Take the 3x squared, divide it by 3x. That is going to be 3 will go into 3 one time. X will go into x squared x times. So our next term in our quotient is x. Take that x, multiply it times the divisor. 3x squared minus 2x. Write that underneath the dividend. Change the sign. Minus 5 plus 2 is minus 3x. Bring down the 4. Repeat the process. Negative 3x divided by 3x. Negative 3x divided by positive 3x is negative 1. Take the negative 1 times the 3x minus 2. That is going to be minus 3x plus 2. Change the sign and add. So our remainder will be 4 minus 2 is 2. So our division results in a quotient of 2x squared plus x minus 1 and a remainder of 2. So we have 2x squared plus x minus 1 with a remainder of 2. Okay, let's continue our discussion. The division algorithm. If f of x and d of x are polynomials, and d of x does not equal 0, the degree of d of x is less than or equal to the degree of f of x, then there exist unique polynomials q of x and r of x such that f of x is d of x times q of x plus r of x. This is the division algorithm. So the dividend is the divisor times the quotient plus the remainder. Dividend is divisor times quotient plus remainder. The remainder, r of x, is equal to 0, or it's of degree less than the degree of d of x, the divisor. If r of x is 0, we say that d of x divides evenly into f of x, and that d of x and q of x are factors of f of x. So if your remainder is 0, your quotient and your divisor are factors of your dividend. If your remainder is 0, your dividend is the divisor times the quotient. All right, let's do this division. We're going to divide 7 minus 11x minus 3x squared plus 2x to the third by x minus 3. I do need to rewrite that dividend so that it's in descending order. So I'm going to write 2x to the third minus 3x squared minus 11x plus 7, and I'm going to divide that by x minus 3. All right, so first term in divisor into first term in dividend, 2x to the third divided by x is going to give me 2x squared. So the first term in my quotient is 2x squared. Take the 2x squared, multiply it by the divisor, 2x to the third minus 6x squared, and write that underneath the dividend. Change that plus to minus, that minus to a plus. I have 2 minus 2 is 0. Negative 3x squared plus 6x squared is 3x squared. Bring down the next term in the dividend, the minus 11. Repeat the process, 3x squared divided by x is 3x. That's the next term in my quotient. Take the 3x times my divisor, 3x squared minus 9x. Write that under my dividend. Got the x on the 11 there. Minus 11x plus 9x is minus 2x. Bring down the 7. Minus 2x divided by x is negative 2. So the last term in my quotient is negative 2. Negative 2 times x minus 3 is negative 2x plus 6. Change the sign. 7 minus 6 is 1. So the remainder resulting from this division is 1. So the quotient is 2x squared plus 3x minus 2 with a remainder of 1. Okay, now a couple of things to note about this division that we just did. The divisor in this division, x minus 3, is a polynomial function, and it's a polynomial function of degree 1. The exponent on the x is the number 1. So I'm taking a third degree polynomial function and dividing it by a first degree polynomial function, and I get a second degree polynomial function. What if I could do this division without all the x's in here? So what if I could do this division just listing the coefficients? Wouldn't this be a lot easier for me to do if I could just do this with all the x's, having to keep track of all those? That's called synthetic division. And synthetic division works when your divisor is a first degree polynomial function. It doesn't work if your divisor is anything but a first degree polynomial function. And this is the way you do it. Okay, so when my divisor is in the form x minus a constant, I can use synthetic division. So what you do is you take the constant. In my case, the constant is the number 3. I take that number 3 and I write it down. And now I'm going to, instead of doing the normal division bar, I'm going to write an inverted division bar. Okay? And now I'm going to put in the same row as the 3, I'm going to put the coefficients on my dividend. Now they need to be written in descending order. So I need to write this as 2x to the third minus 3x squared minus 11x plus 7. And I'm going to write in that same row as the 3 the coefficients on my terms. So I'm going to write a 2, a minus 3, a minus 11, and a plus 7. I only need the coefficients. All right, so now what I do is I go in here and I take the first coefficient in that row, the 2, and I bring it straight down. So I bring it straight down to the third row. So here's my first row, which is my coefficients. And here's my third row. All right, so now what I do is I take that first number in the third row and I multiply it times the 3. So I take the 2 and I multiply it times the 3. So I'm going to multiply. 2 times 3 is 6. I write that in the second column inside that division bar. So I take the 6 and I write it underneath the negative 3. Then I add those two numbers together. Negative 3 plus 6 is 3. And I repeat the process. I take the 3, multiply it times the 3. 3 times 3 is 9. And I write that in the third column underneath the negative 11. Negative 11 and 9, I add those together. I get negative 2. Repeat the process. Negative 2 times 3, negative 6. Negative 6, write that underneath the 7 in the last column, and then add those two numbers together. And you've completed your synthetic division. So what are these numbers? In the third row of a synthetic division, the last number in that third row is the remainder. So this number right here, the 1, is my remainder. The other numbers in that third row are coefficients on my quotient. So the 2, the 3, and the negative 2 are coefficients on my quotient. Okay, so I took a third degree polynomial function and divided it by a first degree polynomial function. So the result I'm going to get is a second degree quotient. I took a third degree dividend, divided it by a first degree divisor. I get a second degree quotient. So the 2, the first 2 there, is the coefficient on my x squared. The 3 is the coefficient on the next term of a lower degree, which would be x. So that's 3x. The minus 2 is my constant, and the 1 is my remainder. And I do believe that's the exact same result we got on the previous problem, which was the same division using long division. We got 2x squared plus 3x minus 2 plus 1 over x minus 3, 2x squared plus 3x minus 2 plus 1 over x minus 3. So synthetic division is a great thing when your divisor is a first degree polynomial function. It makes division so much easier because we don't have to keep track of all the x's. So the way we do this is as follows. Arrange the polynomial in descending powers. with 0 coefficients for any missing term. Well, what do we mean by that? Let's say your dividend was x to the third plus x minus 2. The x squared term is missing. It's not there. So what that means is the x squared term actually has a coefficient of 0. So we could rewrite this as x to the third, maybe if I can write it, x to the third plus 0x squared plus x minus 2. So if we have a term that's missing, we must put that term in using a 0 coefficient. And you have to do this. You can't skip this step, because if you skip it, things don't line up in your columns and your division will be incorrect. All right, the next thing you do is write C for your divisor, x minus c. So remember, your divisor is a first-degree polynomial function written in terms of a subtraction. So it's x minus a constant. So that constant that you're subtracting is your divisor. You're going to write that to the right of the coefficients in your dividend. Now you're going to write the leading coefficient of the dividend on the bottom row. So you're going to bring the first coefficient of your dividend straight down to your third row. You're going to multiply your divisor C by that value you just wrote down. You're going to write that in the second column, and you're going to add those together. And you keep repeating this process until you get all the series of multiplications are done, all the additions are done in all the columns. And then you're going to use the numbers in the last row to write the quotient plus the remainder above the divisor. So the degree of the first term of the quotient is 1 less than the degree of the first term of the dividend. The final value in the third row of your synthetic division is your remainder. Okay, so let's practice this division. Use let's divide x to the third minus 7x minus 6 by x plus 2. All right, so remember, our divisor must be written in the form of x minus a constant. So we're going to rewrite x plus 2 as x minus a minus 2. It has to be written in terms of a subtraction. So kind of the rule of thumb, if this is plus, you make it minus. If it's minus, you make it plus. All right, so we're going to write down a negative 2. Now I have a dividend that has a missing term, so I need to write that in with a 0 coefficient. So now on the same row as my negative 2, I'm going to write those coefficients. So I have a 1, a 0, a negative 7, and a negative 6. All right, I bring the 1 straight down. That is the first coefficient in my quotient. I take the number 1, I multiply it by negative 2. Negative 2 times 1 is negative 2. I write that in the second column. I add those two numbers together. 0 plus negative 2 is negative 2. Now I take the negative 2, I multiply it by negative 2. Negative 2 times negative 2 is 4. I write the 4 underneath the negative 7 in the third column. Negative 7 plus 4 is negative 3. Negative 3 times negative 2 is 6. Write that in the last column. 6 plus negative 6 is 0. So the remainder is 0. Our quotient is, the first number in that third row is the coefficient on my quotient. I've divided a third-degree polynomial by a first-degree polynomial, so I'm going to get a second-degree polynomial. So that will be x squared minus 2x. The negative 2 is the coefficient on the x, and then minus 3 is my constant. Okay, so the division results in a quotient of x squared minus 2x minus 3 with a remainder of 0. Now, I know that if I have a remainder of 0, that means my quotient and my divisor are factors of my dividend. So I know that x to the third minus 7x squared minus 6 is equal to my divisor times my quotient. And that quadratic factor, that's quadratic because it has an x square in it. So I have a linear factor, x plus 2, a quadratic factor, x squared minus 2x minus 3. That factors. To x minus 3 times x plus 1. I have factored a third degree polynomial into a series of linear factors. So x to the third minus 7x minus 6 factors to x plus 2 times x minus 3 times x plus 1. That's pretty important. We'll talk about that in the next section. Okay. The remainder theorem. If the polynomial f of x is divided by the linear polynomial function x minus c, the first degree polynomial function x minus c, then the remainder you get when you do that division is actually the function evaluated at c. For example, if we evaluated the function x to the third minus 7x minus 6 at negative 2, we would get 0. That's the remainder when we did that division. So whatever the remainder we get when we do this division is the function evaluated at that number. Okay? So for example, what's f of x equals 3x to the third plus 4x squared minus 5x plus 3 when you evaluate it at x equals negative 4? Now you could certainly plug in negative 4 for x and take your calculator out and do that. But it's probably faster to use synthetic division, and you don't need a calculator. So how do you evaluate this function at negative 4? You divide it by negative 4 using synthetic division. And whatever your remainder is going to be, that is that function evaluated at negative 4. So bring the 3 straight down. 3 times negative 4 is negative 12. Write that in the second column. Add negative 12 and 4, that's negative 8. Take the negative 8 times the negative 4, that is 32. Write that in the third column. Add those two numbers together, negative 5 and 32 is 27. 27 times negative 4 is negative 108. Add negative 108 and 3, and you get negative 105. So this function evaluated at negative 4 is negative 105. And I'm pretty sure that's probably faster than me taking my calculator out and doing this calculation. And I don't need a calculator to do it. So the function f of x equals 3x to the third plus 4x squared minus 5x plus 3 evaluated at negative 4 is negative 105. And I can find that by dividing that function by x plus 4, or dividing it with synthetic division by negative 4, and getting the remainder. And the remainder is that function evaluated at negative 4. Okay, the factor theorem. And this theorem is extremely important. If you have a polynomial f of x, if f at c is 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f at c is 0. So if you evaluate a function at c and you get 0, then x minus c is a factor of that function. Conversely, if x minus c is a factor, then when you when you evaluate f at c, you have to get 0. And we can use this to solve a polynomial equation using synthetic division. Solve the equation 15x to the third plus 14x squared minus 3x minus 2 equals 0, given that -1 is a 0 of f of x equals 15x to the third minus 14x squared minus 3x minus 2. Got a typo right there. That should be minus 2. Okay, what does it mean that -1 is a 0 of that function? Remember, when a number is a 0 of a function, if you evaluate that function at that number, you get 0. For a given input, in this case -1, the output will be 0. So if it's a 0 of a function, when you input it into your function, your output will be 0. So that means f of -1 is equal to 0. Okay, what else does that mean? What else it means is that if -1 is a 0 of this function, then x plus 1 is a factor. X minus a minus 1 is a factor. So those are the factor theorems, the two parts of this, the factor theorem. So x plus 1 is a factor. Okay, so if I take the 15x to the third plus 14x squared minus 3x minus 2, and I divide it by x plus 1, it will divide evenly with a remainder of 0. So the quotient will be a factor of 15x to the third plus 14x squared minus 3x minus 2. So I can divide 15x to the third plus 14x squared minus 3x minus 2 by -1 using synthetic division and get the quotient, which will also be a factor of this function. All right, so let's just do the division. We're going to divide by -1. And I should get a remainder of 0. So I'm going to bring the 15 straight down. 15 times -1 is -15. Add the 14 and the -15, that's -1. -1 times -1 is +1. Write that in the third column. Add the -3 and the 1, that's -2. Take -2 times -1, that's 2. Write that in the fourth column. Add those together and you get a remainder of 0. So 15 minus 1 minus 2 are the coefficients on my quotient. I've divided a third-degree polynomial by a first-degree polynomial. So what I'm going to get is a second-degree polynomial quotient, 15x squared minus x minus 2. All right? So now we have the 15x to the third plus 14x squared minus 3x minus 2 factors to x plus 1 times our quotient, 15x squared minus x minus 2. Since when I divide this by -1, I get a remainder of 0, then x plus 1 is a factor, and the quotient is a factor. And we're solving the equation 15x to the third plus 14x squared minus 3x minus 2 equals 0. So now I have the equation x plus 1, 15x squared minus x minus 2 equals 0. The first factor there, the x plus 1, we know that gives us the solution x equals -1. That was the solution we were given at the very beginning. The second factor here is quadratic. It's quadratic because it has an x squared. And you have 3 methods for solving a quadratic equation. So what you would do is you'd set the x plus 1 equal to 0 and the 15x squared minus x minus 2 equal to 0. To solve an equation, you factor it and you set each factor equal to 0. And we know this one gives us the x equals -1, which we were given at the beginning of the problem. Now the quadratic, how do you solve that? Well, you can factor it, or you can use the quadratic formula. The square root property doesn't apply here because you have an x term. So you're going to either use factoring or you're going to use the quadratic formula. Now this is factorable, and that I always prefer to factor if I can. The quadratic formula has way too many places to make sign errors in it. So I don't use it unless I have to. If there's no other way to solve it, then I'll use the quadratic formula. This is factorable. Okay, I need 2 factors to put in that last place so that when I do outside and inside, I get -1. So I think I'm going to put a 2 here, and a 1 here, and a minus here, and a plus there. So now we set the 5x minus 2 equal to 0, and the 3x plus 1 equal to 0. Add 2 here, divide by 5. So it looks like another solution to this equation is 2/5. Subtract 1 here, divide by 3, and the other solution is -1/3. So the solutions to this original equation were -1, which is the one they gave me, 2/5, and -1/3. So I was able to solve the equation 15x to the third plus 14x squared minus 3x minus 2 equals 0 by knowing one of the zeros, using synthetic division to find the quotient, which is also a factor of that polynomial. I was able to factor that quadratic factor, and then I was able to set each of those factors equal to 0 and solve the equation. So the 3 zeros, 3 solutions to this equation are -1, 2/5, and -1/3. And that is the end of section 3.3.